Welcome to qnawire.
Hello. Here a ball strikes a wall at 40 with angle at 45 degree, and then it strikes back with the same angle. And we have to find the momentum which is given to the ball and the direction of this impulse. So let's first draw this. Let's try to draw it in a 3D. Let's say this is a wall, and the ball strikes somewhere here. So it's it flows in a direction parallel to the ground, and then it strikes back. So let's say this is Z axis, this is Y axis, this is X axis. Now let's downgrade it to 2D symmetry. So here are our coordinate axes Y and X. The initial angle, so here Y is perpendicular to the wall. So it means that basically this is the initial impulse of the wall of the ball. This is the final impulse of the ball. So as we know, the speed doesn't change, so it means that the initial speed of the ball equals to the final speed of the ball, equals to 25 meters per second. So let's look at the graph more closely. This is the initial impulse of the ball, and this is the final impulse of the ball. So according to the conservation of the impulse, final impulse of the ball equals to the initial impulse of the ball plus the impulse which was transferred, which was given to the ball. So here, as we know, this, let's show the angles. This angle is 45. This angle is also 45 degree. Okay, now let's rearrange this equation and calculate delta P. So delta P equals, of course, in the vector form, equals to the final impulse minus the initial impulse. Or we can rewrite it in some form. So delta P equals to final impulse plus minus the initial impulse. So let's redraw these vectors. Again, this is Y, this is X. So the final impulse of the ball is this guy at 45 degree, and negative initial impulse of the ball is this guy also at 45 degree. The sum of these two vectors can be found from the parallelogram law. So I'm going to use a different color. It basically equals to this vector. So this is delta P. As we know, both alpha equals to 45 degree. Sorry. Yeah, alpha equals to 45 degree. Therefore, the angle between final impulse and negative initial impulse equals to 90 degree. So this angle is double alpha is 90. It means that, it means that the situation is simplified now. Let's redraw this. Let's redraw these vectors again. So again, this is our coordinate axis. This is negative initial impulse. So this is final impulse. And this is the sum. So as we see, the absolute values of the initial impulse and the final impulse are the same because mass doesn't change and speed doesn't change as well. So therefore, this square, this figure ABCD is a square. So then it means that the diagonal of the square, or delta P, equals to, it equals to the square root of final impulse squared plus square initial impulse, or it equals to the initial impulse multiplied by square root of 2. Let's calculate this number. So delta P equals to 0.060 kilograms multiplied by 25. 25 meters second, and multiplied by square root of 2. So let's calculate this value. It equals to 2.1 kilogram meter divided by second. So this is a absolute value, absolute change of the impulse. Now we have to find the direction. Again, as we can see from the square, the direction is directed along with the y-axis. So it means that delta P is perpendicular to the wall. So therefore, we can summarize our results. Absolute value of delta P equals to 2.1 kilogram meter per second, and delta P is perpendicular to the wall. So, and more specifically, delta P is directed from the wall. So delta P is directed from the wall. So this is the answer to this question. Thank you very much for submitting it. I hope I helped you. Bye.